Good afternoon, everybody. My name is Sally Ann Spence, and I am so excited to be bringing you an amazing live lesson today because we are actually at the British Antarctic Survey's headquarters in Cambridge. But we're not just going to be meeting the scientists and engineers that are based here. We're also going to have a live link, hopefully, to the scientists and engineers that are based on the Rothera research station, which is all the way down in Antarctica itself. Now today, I want you to start thinking about questions as we go through the lesson. Think about those questions that you might want to ask at the end of our lesson. So think about those all the way through. And you can take part with other questions and word clouds that I'll be asking you about by using your Slido. Also, you can see behind me, this is a beautiful backdrop. It's interactive and you can have a look around it, have a look on the website and use your resource button so you too can have a look around Rothera Research Station. Now, let's look at what we're going to be going through today before we meet our first guests. What we will be learning about today. We'll be learning about the unique characteristics of the Antarctic environment and how human activity can impact on it. We'll be learning about the challenges faced by the scientists and engineers working in Antarctica. Also, the importance of studying Antarctica and the career opportunities related to polar research. And the work of the British Antarctic Survey to address issues of global importance and help society adapt to a changing world. Let's meet our very first expert, and that person is Vicky. Hi, Vicky.
Hi, Sally Ann.
Now, Vicky, what do you do?
One of British Antarctic Survey's pilots. So I fly their two types of aircraft into Antarctica and spend about 5 months a year flying aircraft in and around Antarctica.
Now, tell us first of all, whereabouts is Antarctica?
It's a long way away from here. Some people call it at the bottom of the world, but it's pretty much the centre of my world, certainly for half of the year. And if you imagine flying down from America through South America and then finally south of South America, you'll find the Antarctic and the Antarctic Peninsula, which is where Rothera is.
So now this is the station here. This is Rothera Station in Antarctica. Whereabouts do you land your planes and take off from your planes?
This
on
is
the runway?
A stunning picture of Adelaide Island, and you can see most of the accommodation in the main bases here. What this bit here is might look like a road. It's actually a snow-covered runway, and we land our aircraft there. And then once we've landed our aircraft, we move them into the hangar.
Into the hangar. So we're inside the hangar now, and we've got 3 or 4 planes in here, 3 planes in here. Can you tell us a little bit about them? Because they're not all the same type of plane, are they?
No, that's right. We have 2 different types. One's the Dash 7, and that's this big one in the centre. You can see all of them are propeller planes. This one has 4 engines, and that's our main plane that we use to bring people into Antarctica from Chile or from the Falkland Islands. And then once we've got them to Rothera, then some of the scientists particularly will transition onto these smaller aircraft, the Twin Otters, and we'll take them deep field into the Antarctic continent where they'll get to do their science.
Well, I can see on this plane you've got wheels there, and on the other planes you've got wheels, but it looks as though they've got skis or something on them as well.
That's correct. So these smaller aircraft, the ones that actually go into the deep field, can land either on the runway on wheels, or they can land on skis, and then they can land on ice or snow.
Well, you can't take off with your planes and you can't land your planes without a runway. Can you tell us a little bit more about the runway, Vicky?
Of course I can. This runway that you see here, it's covered in snow at the moment, but it's basically made of crushed gravel. So just like a road, you start with very large rocks and then you gradually fill up layers with smaller and smaller rocks until the very top surface is made of small stones like this. This isn't from the Antarctic, by the way, it's just from outside the building here. And then they get rolled with very heavy machinery flat so that it's a safe runway for us to land on. But over the years, this runway was built over 30 years ago. It's had a bit of wear and tear because every time we take off, there's a pile of dust and snow that gets pushed off the runway and into the sea. So just last year, we had a runway upgrade. And basically the whole of this surface, 900 metres of it, was resurfaced so that we've got a nice fine gravel surface again, nice and smooth with good drainage off the sides and some happy pilots.
So it must be quite important to have the drainage as well.
Absolutely, yeah, because obviously over the winter, while we're not here, then this snow can build up to over 1 metre high, and underneath that there will be some ice, and that will need to melt off over the early summer season. So yeah, drainage is super important.
And do you have lights on the runway? Have you got new lights going in?
We had some upgraded lights, so at both ends we have runway edge lights, and we also have some lights that are difficult to point out here, just here, that help us with an approach path to land onto the short runway, because it's quite a challenging runway. And this is an important runway for not just the British Antarctic Survey's aircraft, but all the other operators that run small aircraft into the continent. So it's basically like a gateway into Antarctica.
When you're flying the planes, you're not just carrying scientists and equipment backwards and forwards, are you? You're actually doing some science work yourselves.
Yeah, that's actually one of my favourite bits of flying in the Antarctic, is where we put some science equipment and instrumentation in the aircraft and actually go and fly a survey, maybe looking at seal populations or measuring the depth of the ice over the continent. It's really great to be involved in that kind of direct level of science.
Now, I believe we've got a video of you flying planes here. This is from the pilot's eye view almost, coming in.
That's right. This is coming in from the south, so in a Twin Otter. So we're probably bringing scientists back after them spending between a month and 3 months out in the field. So they'll be very grateful to be landing back at Rothera, looking forward to hot showers, maybe even some fresh food. You can see the runway's quite short. I mean, we're a very capable aircraft that can land on very short runways. It's specifically designed to do that. It doesn't take much of the runway to come to a stop, as you'll see here. And then you can see the buildings on the right is the main base, and then just coming into view on the left-hand side is the hangar. And we have 4 Twin Otters and 1 bigger Dash 7, and we can get 3 of the Twin Otters and 1 Dash 7 into the hangar.
So there's modernisation has gone on with the runway. Anywhere else on the station?
Well, along with the runway that was also 30 years old, we've got some even older buildings that are in need of an upgrade. And a lot of the support staff we've bring in recently are the construction team that are building and upgrading the main accommodation buildings.
Who, if I wanted to speak to somebody next, who would I be speaking to?
I believe Ellen is actually in Antarctica, so I would definitely get in touch with Ellen.
Well, thank you for taking us through that.
You're
and
welcome.
I think it's time now for us to go and find Ellen. This is going to be so exciting because we're going to be doing a live satellite link with Ellen on Rothera's research station. So very excited about that. But before we talk to Ellen, thank you once again, Vicky, because Vicky will be with us for our question and answer session at the end of this, won't you, today? Mm-hmm. So be thinking of anything you want to ask her about planes and flying in and out and the logistics of being able to do that. And now it is time to take part in our very first question. What things are important when modernising a research station in Antarctica? Is it A, environmental impact, B, energy consumption, C, technology to improve efficiency, or D, how it looks? Well done, everybody, for taking part in that last question. The answers are that A, B, and C are all really important. Right, now, very exciting because we're on a Zoom call live with Ellen, who's in Antarctica at the Rothera Research Station right now. Hello, Ellen. Can you hear me?
Hi, Sally-Ann. Great to see you.
Now, tell me, whereabouts are you in the Rothera Research Station right now?
So currently I'm in the operations tower at the station, which gives us a 360 view of the station and is able to support our aircraft operations and our field operations to make sure that we can do that all safely and we look after everybody that's here on station.
Okay, so I'm going to just point this out. So right now, Ellen's in here, this part of the building just here. And what's the weather like right now then, Ellen?
Certainly getting colder and very windy today. We've got high winds today, not so much snow building, but we've certainly got some accumulation already. So we spend quite a bit of time clearing snow to make sure everyone can go about their day-to-day activities.
Wow, and how cold is it? It must be quite cold then.
It's certainly getting colder, so we are now at about between -5 and -10, depending on what the wind is like, and that has a major effect on how cold it feels. But we're all very well kitted out to make sure that we're nice and warm and we keep safe throughout.
Oh, wow. Now, Ellen, can you tell us your role that you actually do on the station?
Certainly. So my role is Programme Director for the Antarctic Infrastructure Modernisation. People wonder what does that mean, and it's really taking the time to look at a programme of work to redevelop the station. The station has been here since the 1970s, and some of the buildings have been here since very early in that period. So they are getting quite old, tired, and being very well taken care of, but now they are due for replacement. So the programme that I'm responsible for is really looking to modernise those facilities to make sure that we can continue to deliver our world-class science from this station.
And what's it like actually living there when you're there?
It's a great experience, and you have to remember that it is people's home and their workplace, and so you've got a combination of activities and buildings here to support that. We all eat together, we do recreation together, so it's really important that we have a great community feel here. And you do have to also take all your gear on and off as you go between buildings. So that's an extra bit of work that we have to build into our time as well. But there is a fantastic community spirit, and everyone helps and supports each other when you consider we're in a hostile environment and you are a long way from home. So it's really important to have that linkage together.
Because this communication we've got now is incredible, just to be able to see you there in Antarctica right now.
This season we've been very fortunate with some new technologies that have been deployed, and we can actually have these conversations. It's been so important from a welfare perspective for the team, so they can keep in contact with their families.
Well, we're really excited because later on you'll also be helping us to answer some of the questions on Slido, I think, as well.
Yes, I'm hopefully be able to respond to some of the no doubt challenging questions we'll get from the audience.
I hope so. I hope you're all thinking of some questions to ask Ellen and everybody else a bit later on today as well. Now, Ellen, can you tell us a little bit about another building not far, well, which is part of the building actually you're on top of right now, isn't it?
It is indeed. So the Discovery Building is the primary project that we're working on at the minute. A lot of work has been going on it this season. We've been working a lot around the internal fit out, so making sure that it's not just a big blank building. We've got rooms, we've got spaces for everybody within it, and we've got now fitted windows as well, so everyone can see the wonderful environment that we're in as well.
Now, the person to speak to about the Discovery Centre building?
So I would recommend that you speak to Elliot Perez about the Discovery Building. He'll be able to give you more details about what's included within it and the work that we've been doing so far.
Well, thank you so much, Ellen. I'm just blown away by the fact we can chat to you like this in such an incredible place that you are right now, right down there at the bottom of the planet. It's incredible. So thank you for talking to us. And right now, I think it's time for us to go into a Slido while we get ready to have a little chat with Elliot. So thank you again, Ellen. And our question is going to be, what are some of the things you think the Discovery Building may contain? So think about it. What else do you think you might find in the Discovery Building? So let's have a look at some of the answers. A, an area for science and fieldwork equipment. B, a room for producing power, heating and fresh water, which is really important for the scientists to be able to drink and as well. And C, a medical centre. And there's also D, a climbing wall. Do you think there's a climbing wall in that building too? We look forward to your answers, and in a minute we're going to chat to Elliot. I hope you got the right answer, because the answer is actually all of the answers. They're all contained within the Discovery Building itself. And here's Elliot. Hello, Elliot.
Hello, it's Mike from Rothera.
Elliot, what is your role on the research station?
I'm the Assistant Project Manager for the AIMP. I've been on station since February, and I'm helping to oversee the construction of the Discovery building from a BAS perspective.
Wow. So this is a really, really important new building that's still very much in construction, actually, because I can see that you're still building it right now. Can you tell us a little bit more about the building and what's in it?
Yes, so the Discovery building will be a new state-of-the-art operations and science support facility down at Rothera. It's actually the UK's largest research station and has been in construction since 2019 and is due to complete next year, which will actually mark 50 years since Rothera was initially established.
So, can you tell us why some of those things are so important for the everyday life on the station, as well as all the science you're doing?
Of course, yes. So we live in one of the most remote places on Earth. So inevitably, we have to be able to sustain life. And one of Discovery's main roles is to provide power and fresh drinking water for the station. We will do this through 4 combined heat and power generators, which, as a byproduct of the power generation, will also produce heat, which will be distributed across the station. A common misconception as well is that we get our drinking water just by melting snow. And whilst we do this in the field on a small scale, inevitably when we have 80 to 100 people, this isn't feasible. We actually use something called reverse osmosis. So we have a reverse osmosis plant which takes the seawater, because we're on the coast, and draws out the impurities and gives us a constant supply of water.
Brilliant. Well, we've got a little bit of a film here that's going to enable us to have a look inside the building. So we're at the doors here. We're going to go inside. And the very first room we're going to come up to is the boot room, I believe. So it's a boot room as it says, the boot room.
Yes, it is indeed. A big part of being in Antarctica is being able to put a lot of gear on and take it all off multiple times a day. So it's important to have the boot room right next to the entrance so we can not trudge snow all through the buildings.
And then we're going from the boot room and we're going into the medical centre here. Now, a medical centre would be very, very important because as you said, you're cut off from everywhere.
Exactly that. We can be weeks away from help sometimes. And with 80 plus people on station, inevitably things do happen. So it's important to be prepared. The Discovery building's new medical facility is actually split into 3 rooms plus a 4th storeroom. So we aim to have all the same kit we would have in the UK to keep people as healthy as possible.
So we're seeing lots of different areas where you can actually just, as I say, keep fit, because that's really important, presumably, down there with...
Yeah, so the weather can get pretty tough sometimes, which does confine you to being indoors. So in the Discovery building, we've got various rec spaces. We have a gym, which is going to be equipped with everything you would find in a typical UK gym. And it's also connected to a sauna. I think that's really important to provide that rec. We also have other physical areas, such as a climbing wall, which is actually spread out across 2 stories and has an auto belay, so people can get in a few different routes there.
Elliot, we're looking at some workshops here. We haven't just got workshops, we've got a heavy workshop. And it looks like a big bulldozer in there. Tell us a little bit about that.
Yes, so BAS has a massive vehicles operation. It's integral to keeping the station running, from everything from snow clearing on station to keep operations going, to prepping, to getting skidoos and the piston bully out in the field.
Right, so now we're going to have a look up here. Let's see where we go next. And we're actually going up the comms tower stairs, all the way up the stairs you can see on the video here. And where we're going to end up is the room where Elliot is right now. So here we go. And you can see all the windows in the room. So looking across to you right now on Zoom, Elliot, you're stood there. We're seeing you on the video and stood there. Can you give us a little show round once again?
Of course, as you can see behind me, it is very windy today, very white. I'll show you over here as well, out to the coast.
Look at all that snow. And we can see those little tiny icebergs almost out there in the water, in the sea.
They are icebergs indeed. Tiny is not a word I'd use to describe them. They're a lot bigger than they first appear. Wow,
that's incredible. I cannot believe that we're talking to you live right now in Antarctica. very end of the world. Look at that, incredible. Now there's so much technology in the whole research centre station as well. Who else can we talk to about the technology that's being used there now?
I'd recommend going back to Carl Robinson.
Carl, right. Okay, so we've got to now find Carl and have a chat to him. That's incredible. Thank you so much. That was brilliant to chat to you, Elliot. Have a fantastic day in the snow.
Thank you. See you later.
Thank you. Before we meet Carl, I've got another question for all of you to take part in. So are you ready? Here we go. Which of these technologies would future scientists not use to explore, study and survey the extreme polar environments? A. Robots, B. Hand gliders, C. Drones, or D. Satellites? So many of you took part in that last question. Well done. And the answer is actually B, which is hand gliders. Hand gliders are not used. And somebody who can tell us more about all the technology that they're using is Carl. Hello, Carl.
Hiya.
Carl, can you tell us a little bit more about what you do at the Rothera Research Station?
I'm an engineer and I fly around in Antarctica in the Twin Otter, and one of the big jobs we do is actually measure the ice thickness, and this reveals the underlying surface of what's actually underneath the ice in Antarctica, and the ice can be up to 4.8 kilometres thick. So using the Twin Otters with a radar on, we're able to see through the ice, and it's very interesting because we can actually see the internal layers, just like looking through the layers of a cake. I've got a cake here just to demonstrate it.
Oh, you've got a cake?
Yes.
Carl's bought a cake. Brilliant. We love cake.
So,
oh, look at this.
When the radar is working, we send out an RF signal, and it goes down through the ice.
So what's an RF signal?
Basically a radio wave,
right.
Similar to how your radio works. And so the signal goes through the ice, down through the ice, through the surface, and then what's interesting actually is once it's gone through the ice and the scientists have processed the data, is
look at all the layers.
We can see individual layers, and the individual layers actually show some major events such as big volcanic eruptions or actually different changes in the climate. But what is interesting, moving forward, we're going to start to use drones, and this is key to sort of the future and helps us to get towards net zero with a lower carbon footprint. This season we've been flying the Wind Racer Ultra in Rothera as early stage sort of testing of drones to see how we can use them and test our sensors on them.
I think we've got some video. If we got a video, that here we are. This is the Wind Race then here.
That's the Wind Racer Ultra, yes. So this season we were down in Antarctica, flying various sensors. And this allows the scientists to prove those sensors work. So in future years and for future scientists to come, there is the potential that some of the science will be delivered on drones similar to this, and also other drones.
So this is a huge aircraft though. This is a big drone.
It is a big drone. So it is our first attempt to use such a large drone, and it's key in terms of flying larger scientific instruments that we currently fly on the Twin Otters. So yeah, going forward it will be a key resource for the scientists to use.
And you're using smaller drones as well?
So yes, over the years the scientists have used a vast number of these quadcopters, and these are very good at actually doing wildlife censuses and yeah, observing the wildlife in local areas.
So right, so this is a drone which we're more likely used to seeing. I'm sure if you've seen drones, it's very similar to this type of drone here.
Yeah.
And you're using these drones for surveying wildlife and things as well.
Yeah, so our scientists have, over the years, have started to use these an awful lot. It's a very effective local area sort of aircraft for actually surveying sort of the wildlife. So they've used them to survey penguins and seals in the local areas to do wildlife census.
So have you got some images? We've seen some images down here. We're going to try and lift up some of these images now. Let's have a look. See if we can show these to the camera. Now this one isn't taken in Antarctica though, is it, this one?
No, our scientists actually study the sort of the polar environment, so often they work up in the Arctic as well. So here you can see some walruses.
Oh yes, I can see them just down here. Can you see these just down here? This is our walrus colony.
So our scientists actually use a vast variety of sort of sensors, even sort of satellites. Satellites are actually a key tool for actually some of our scientists to actually establish whether there's wildlife in the area and do sort of wider area census. And then you come down to aircraft, which then can be able to create that sort of higher resolution type survey of the areas. So the aircraft are a key resource in terms of filling in the sort of the knowledge gaps for our scientists.
Wow, we've got some more images down here. Can we just lift these up and show people as well? Because I think these are from Antarctica, aren't they? I'm going to have to turn them around here. So what are we looking at here?
So these are images some of our scientists have got from satellites and have worked on and actually discovered sort of unknown penguin colonies. So sort of a big part of some of our scientists' work is actually understanding what the wildlife is doing, and obviously that's a true reflector of the health of the Antarctic environment.
So you can see the penguins, and is this sort of brown colour penguin poo then, is it?
It is technically penguin poo, yes.
So where you have penguins, you have penguin poo, but
penguin
it does show up really well from above.
So it's often the penguin poo that identifies the colony first, and then they look closer.
Thank you so much for telling us all about that, Carl. It's really, really interesting. You're using all these aircraft to get all that information, so it's fantastic. And thank you for the cake. I think we might keep that for after the questions and answers session. Thank you.
Thank you.
Right, well, before we speak to Ryan, I want you to take part in a word cloud. Can you name any animal life you think may live in Antarctica? Now, some really good input on that word cloud, and well done to all of you for having a go at that. And with me is Ryan. Hello, Ryan.
Hiya.
Can you tell me a little bit about what you do at the Rothera Research Station?
Yeah, so I'm a marine biologist. I've been going down to Rothera for the last 4 years, where we monitor the oceans. So we monitor temperatures, the salinity of the oceans, and we also collect animals. We collect animals on a monthly basis. And so we can monitor how these are changing throughout the year, and as it's a long-term time series, we can see how these things are changing as our climate changes, which is a really important thing to do.
Well, we know that the climate is changing, so this is really, really important research, isn't it, altogether?
It is, absolutely, yeah. So it's a really unique data set as well. We're so remote in this world, there's no one around us doing anything like what we're doing.
Well, you're in a pretty remote place to be doing it as well. And it's not just the marine, which is the sea wildlife. You've also got wildlife on the land as well, haven't you? You've got these guys.
We do. We have penguins. There are 18 species of penguins in total, but we get 2 of the species on the station around where we live.
A lot of you will be doing adaptation at school, and these birds here are flightless. Why are they flightless?
So in Antarctica, there are no predators on land, so there's no need for these birds to fly. They get all of their food from the water. They eat the krill. So krill is a really important food source in Antarctica. It feeds all the penguins, it feeds the seals, it feeds the birds, it feeds all the whales.
So can you tell us very quickly, what is krill then? You say it's tiny and it feeds something as big as a whale, so what actually is it?
So krill is a small crustacean similar to a crab or a lobster, and they swim in the water column. They're about a couple of inches long.
Feed everything.
Feed everything.
This is the downside of being the tiny thing, isn't it?
Absolutely.
And have we got any other sort of animal that comes onto the land at all in Antarctica?
So we've got lots of birds. A lot of the birds in Antarctica, they migrate from the warmer regions. During the summertime, they migrate into Antarctica, where they can feed on this really abundant krill. We also have some seals. They do come out on land. They come out on land to rest, to breed, to look after their babies. Antarctica is really unique because of the extreme environment, because of the cold weather, because of the cold waters. Animals have adapted to be able to survive in these conditions.
That's fantastic. Well, talking about that, we're going to have a look at a little bit of a film now of the seabed itself, and I'm going to ask you some questions as we have a look at it. It's so brilliant. Look at all the life on that seafloor. I didn't think there'd be so much life down there. It's so cold.
Yes, it's a really abundant ecosystem. There's lots of life. And a lot of these animals are a lot larger than we see elsewhere in the world. Some of these sea squirts here, they can be up to 10, 15 centimetres high. A lot of this is also really slow growing. Because of the cold waters, everything happens really slowly in Antarctica. So some of these stuff can be decades old, if not older. And it's all really unique. Antarctica is one of the regions in the world which has got the highest endemism, which means most of the animals here in Antarctica, they only occur in Antarctica and nowhere else in the world. So it's a really unique environment.
So why is it so important then that you study here? Because it's in a unique environment, or because it's telling us so much about what's going on around the world, especially with climate change?
So there's lots of reasons to study the wildlife in Antarctica. One of them is because it's unique, you don't find it anywhere else. The other reason is Antarctica is one of the areas that's changing most from climate change. So it's really important to study these systems, to study these animals now, because it will help us to understand what will happen in the future, and we can take what we learn here to other areas in the world.
How do these animals adapt to their scarcity of food and things like that then in that case?
So a lot of these animals, they eat when they can, but then they don't eat for long periods of time. So they might not eat for months at a time. Having said that, food can suddenly become really abundant. So we mentioned earlier about the krill. During the summer months, the krill feeds on phytoplankton, which is a tiny, tiny algae in the water. During the summer, with all the daylight, the phytoplankton blooms, the water goes green, and all of these animals here, most of what you see here, feeds on these tiny, tiny microscopic algae.
Wow, look at that. Now, we've got on the table here, we haven't seen any of these in the film, but these are also found in Antarctica, aren't they? And these are really cool. Look how cool these are.
They are. So this here is called a Glyptonotus antarcticus. It's a giant isopod.
Right.
So this animal is related to what we get woodlice in the UK. So those tiny little shelled insects that we find around our homes. So this is the very similar species. And you can see the size difference. A woodlouse is about 1 centimetre long, and this can get up to 10 centimetres.
And why, then in that case, why are these things getting so big in Antarctica? And we don't find them as big as this in oceans anywhere else?
One of the reasons they get so big is because the water is so cold, it's able to hold more oxygen. And so these animals are able to support themselves in much larger sizes than they can elsewhere in the world.
That is amazing. And we've got something here. This is big as well. This is
what we call a sea spider. It's not actually related to a spider. It's more related to crabs and lobsters. But we call it a sea spider because of these long legs. What's really cool about these guys is they don't have a vascular system. So they have no blood vessels. How they get oxygen around their body, because there's so much oxygen in the water, they're able to absorb the oxygen directly through their legs.
Through their legs. That's amazing, isn't it? And look at the size of it. Look, that's my hand. They are massive. And these, I just think, are so cool. I'd love to see these running around. They're absolutely amazing creatures. Well, I've got so many questions to ask Ryan, and I hope you have too. Ryan, you are going to stay on for our question and answers in a minute,
Absolutely,
aren't you?
yeah.
Brilliant. Do keep thinking of all those questions. You must have some more by now. There's just so much. What an incredible lesson we've been having today. Thank you so much for that, Ryan.
No worries.
Before we go to the Q&A, teachers, please can you spend 30 seconds to fill out your feedback forms on your Slido. It's really, really important to us because it helps us deliver more lessons just like today's. Now, let's have a look back at exactly what we've been learning about today. First of all, we met Vicky, and Vicky told us all about the planes that she flies and the runway that she flies them into and out of, and she does a very important job. Then we met Ellen, and she told us all about the modernisation that's going on right now at the Rothera research station in Antarctica itself. Do you remember? We were live linking with her. And also, we were live linked with Elliot, and he told us about the Discovery Building, and he took us on a little bit of a tour round. Do you remember? We saw all sorts of different things that the scientists have to help them relax. And after him we met Carl. He told us all about drones and wind racers, and best of all, he bought some cake. Do you remember seeing that? That showed us how the radars worked. And then finally we met Ryan, and Ryan told us all about the wildlife, both that lives in the sea when it's really, really cold in that water, and also on the land. What an incredible lesson we've had so far. I know we've got loads of questions coming in. Please keep them coming in. We've got Ellen, who's right now at the Rothera Research Station, and she is busy answering your questions on Slido. We've been joined again by Vicky. Hi, Vicky.
Hi again.
And of course we've got Ryan here.
Hey Sally, hey everyone.
So we've got so many questions, we're going to go straight into it, I'm afraid. It's going to be a bit of a quick fire thing. Right, let's have a look. So, Hollybrook Junior School, Oscar would like to know, how fast can the otter plane go?
Oh, Oscar, the Twin Otter can go at about 190 miles an hour.
Wow.
But it goes at about 170 miles an hour when it's got skis on with more drag. So it takes about 6.5 hours to get from London to Rome, just to give it. So it's quite a slow plane.
Gosh, yeah, well, I don't know, that seems quite fast actually. Right, let's have another look at a question. Appleton Academy, have you ever hit an iceberg? Have you ever hit, it's a bit like the Titanic. How cold is the water and why doesn't it freeze everywhere?
Oh, that's a really great question. So as one of the marine scientists, a lot of my work is working off of boats. So we have small boats, we take them out into the water, and the whole area, the whole sea is covered in icebergs, from huge icebergs which are bigger than your house to tiny little icebergs about the size of your hand, and everything in between. And we often have to maneuver the boats through these different sizes of the ice. So sometimes we actually have to crack the ice to get through, sometimes we have to take big wide diversions to get around it. And the sea, the reason why it doesn't always freeze is because of the salt in the water, it lowers its freezing point. So the seawater actually freezes at minus 1.8 degrees Celsius. So it's colder than the normal freezing point that we get with fresh water. So during the summer periods in Antarctica, the sea is generally open as the air temperature has warmed up. And then during the winter, when the air temperature gets colder, the sea will get to that minus 1.8 degrees and then it will start freezing.
Golly. And how far away does the ice sheet extend from Antarctica?
So during the winter, in the middle of winter, the so-called mass of the Antarctic area almost doubles in size as the sea ice extends from the edge of the continent out into the sea. So it almost doubles the entire continent.
Golly, that's quite a lot of ice, isn't it? Right, let's have another question. Hurricane class, they want to know, how are supplies delivered to you? Ooh.
Well, I guess I get involved with delivering supplies with the aircraft. So the bigger aircraft we talked about, the Dash 7, can bring in some fresh supplies, which are always really welcomed when we have a little bit of payload availability. But generally the supplies are brought in by the Sir David Attenborough ship, which is a very large research vessel that's also used as a supply ship for Rothera. So maybe 3 times a year we'll get supplies in that supply the station with food for the whole of the year, along with everything else that we need to survive.
That's the thing, because once you're down there, that's it, isn't it? You're stuck with it all. Right, let's have another question. Loads of questions. Keep those questions coming in. This is brilliant. We've got loads of questions. Elm class would like to know, from Hollywell Primary School, Oh, here we are. This is a big question, actually. What information are you collecting, and how do you record the data you collect? That's a really good question.
Oh, wow, and, yeah, another great question. So again, as part of the marine side of things, the water side of things, we take water samples where we look at what's growing in the water, what chemicals are in the water. We take physical samples of animals, so we actually collect animals. And we also take lots of imagery. So as a scuba diver in Antarctica, we go down with cameras, we take lots of photos of the seabed, but we don't just do marine work, we also do atmospheric. So every day we launch balloons that go up into the atmosphere, and they collect lots of data about the chemicals that are in the different layers of the atmosphere. And it's not just data that we collect on the stations, we actually collect data out in the fields. I don't know if Vicky wants to answer that.
Neatly handed over to you, Vicky, there.
We talked a little bit about collecting data on aircraft. So sometimes we're actually taking pictures from the aircraft or from our drones, and we can count the number of seals and other wildlife during the population survey censuses that we do. And other work that I think Carl touched on was also the data collection of the depths of the ice and the type of ice on the continent as well. And as well as that, we also drop instruments into the deep Antarctic, and the scientists will leave the instrument measuring everything from weather to the tiny movements of rocks, and they'll leave the instruments there for a year or two, and then we'll go and pick up the data in a year or two later.
I mean, it's everything it is. It's a research centre station, isn't it? So there's so much research going on. So that's a brilliant question. Right, Sherborne Prep School, Class 4A. How long does it take to travel to Rothera Research Station? So how long does it take to travel, I presume, from the UK?
Yeah, so that's for passengers that are coming in on the Dash 7 aircraft that will usually leave from the southern point of Chile. It usually takes about just under 2 days to get to Chile, and then you may or may not get straight on an aircraft and straight into the Antarctic, so you would be there within 2 or 3 days. Or you may wait for 10 days because the weather's so terrible at Rothera that we can't actually do the air bridge for 10 days. That would be a long wait, though.
A long wait, though.
Yeah.
Right, okay, keep going. There's some brilliant questions. Right, Holmeswood Methodist School would like to know, how do you deal with litter and waste? Now, this is quite an important one as well, isn't it?
It's really important, yeah. So we do our very best to take as little as possible down to Antarctica, and we also take everything back out with us, or as much as we can. So a lot of our waste, we store it in containers, and then it goes back on the ships at the end of the year, and it gets brought back to the UK for processing. What little sort of biological waste we do produce, we actually incinerate it through, and it goes through various filters. So we try and leave as little as possible in Antarctica, and we're very careful with the resources that we bring down to Antarctica.
Yes, so everything you bring down you try and take back.
Yeah.
We've just had some more questions come in. I'm going to quickly grab these. This is brilliant. We really have got loads of questions. Thank you very much, my elegant assistant there. Right, we have got Egrant Primary. How do you scuba dive when it is so cold?
Yeah, brilliant.
Why do you scuba dive?
Why do you scuba dive when it's so cold?
So we wear what's called dry suits, and these dry suits, they're thick neoprene layers, and we wear really thick undersuits. So we've got so many layers on that we can barely move, but that keeps us warm and it keeps us dry. We're underwater for between 20 and 30 minutes, which is quite a short dive compared to if we were elsewhere in the world. But that's 30 minutes, we get really cold, even wearing all of our layers. But we are dry, so that's how we can survive.
Brilliant, brilliant. Right. 5WM would like to know, how big are the sea spiders? So we saw the sea spider earlier with you, didn't we? How big are they getting?
We did. So that was probably as large as they get. So they get about dinner plate size. We've got a number of different species, but only 1 or 2 of the species actually get to that size.
Okay, this is also, I'm sorry, I keep firing questions at Ryan here. Very last question here, well, one of the last questions. Joshua wants to know, how many penguins are there in Antarctica?
There's around 20 million.
around 20 million. And we're going to have to finish. I'm really sorry, so many questions, but we're running out of time. Laurel class would like to know, what's your favourite thing about Antarctica? And you've got to be a really quick answer.
Oh, the peace and the majestic scenery that we get to see when the weather's good.
So the peace and the scenery.
I love the ever-changing landscape with the changes of the icebergs and the movement of the icebergs.
Well, I think you're working in an amazing environment. I'm sure all of you do as well. I'm afraid it is the end of our session, our question and answer session. We've had an amazing lesson today. Our alarm's going off to say that's it. So you can access any of the lessons we've already done on demand. You can also have a look at the interactive map we've got of the Rothera Research Station, sorry, I keep saying Centre, on our website, which is stemlive.co.uk. And thank you to you, Vicky, to you, Ryan, to Ellen, who's on Rothera Research Station, and also everybody else here at British Antarctic Survey who has enabled us to have this lesson today. It's just been incredible. And now it is time for us to say goodbye. So goodbye, everybody.
Bye.